Hello, hi everybody. This is your Raj Reddy sir. Today I came in front of you with another science related topic, ninth class motion, numericals in motion. We already discussed some few basic questions in the previous video, numerical problems. Today extension, other numerical problems in the same topic we will discuss. So here question number 7. In long distance race, the athletics were expected to take 4 rounds of the track such that the line of finish was same as the line of start. Suppose the length of the track was 200 meters. First question they are asking, what is the total distance covered by the athletes? So here length of the track is given, length of track is given 200 meters and athletes were expected to make 4 rounds. So what we have to do, when they are completing 4 rounds, then the distance covered by the athletics will be, because they are completing 4 rounds, 4 into distance of the track, length of the track, so 4 into 200, which is 800 meters. This is first question answer. Now second question answer, B. What is the displacement of the athletics when they touch the finish line? So here what happens, in question it is mentioned that finish line of finish was same as the line of start. When line of finish and line of start both are same, athletics reach the initial point again. Final point and initial point coincide each other. So in that case, we discussed already, displacement will be 0 because there is no change in initial and final points. So displacement is 0. Distance is 800 meters, but displacement is 0. Is the motion of the athletics uniform or non-uniform? Question number C. It depends on the speed or velocity maintained by the athletics. So if athletics maintain constant speed, then motion will be uniform. Uniform motion. They cover equal distances in equal intervals of time. Otherwise, it is non-uniform motion. Hope you understood this. Now next answer is the displacement of the athletics and distance covered by him, athletic and distance covered by him at the end of the race are equal. No, because distance covered by athlete is 800 meters, whereas displacement covered by him is 0. They both are not same. Distance and displacement both are not same. Hope you understood this question answer. Now let us discuss next question. Question number 8. In question number 8, it is given, starting from a stationary position, Bhuvan pedals his bicycle to attain a velocity of 6 meters per second. So here one very important point, starting it is a stationary position. Stationary position means rest position. When object is at rest position or Bhuvan is at rest position, then what we have to take? We have to take initial velocity as 0 because starting he is at rest position. Then he attains a velocity of 6 meters per second. Means what? Final velocity is equal to 6 meters per second. This we have to Keep in mind, initial velocity is 0, final velocity 6 meters per second, and time is given, time is equal to 30 seconds. So now they are asking, then he applies brake such that the velocity of the bicycle comes down to 4 meters per second. So this is case 1. In the first case, what happened? He was at rest position, then he came to 6 meters per second in 30 seconds. Then in the second case, what happened? Here initial velocity is 6 meters per second. Now, as of now, his velocity is 6 meters per second. But later what happened? That 6 meters per second velocity comes down to 4 meters per second. Means what? Final velocity is what? 4 meters per second. Initial velocity 6 meters per second. Final velocity 4 meters per second. This is in time. This is in 4 seconds of time. 5 seconds of time. So here two cases are there. In first case, what is the acceleration, and in the second case, what is the acceleration we have to find. So case 1 solution. What is the formula? Acceleration is equal to final velocity minus initial velocity by time. Change in velocity. Acceleration means change in velocity. So final velocity minus initial velocity by time. So here we will substitute that final velocity is 6. You know it is 6 meters per second, and initial velocity is 0 in the first case. And time is 30 seconds. So what it is? 6 by 30 after cancellation 1 by 5. If you convert that into decimals, it is 0.2 meter per second square, because it is acceleration. This is answer in the first case. Now let us find out answer in the second case, case 2. In case 2, what happened? We have again formula is same. Final velocity is 4 meter per second. Initial velocity is 6 meter per second. Time 5 seconds. So his speed is decreased now. So what we call it? Now minus 2 by negative acceleration. Minus 2 by 5, which is nothing but minus 0.4 meters per second square. This is what? Acceleration in second case. Hope you understood. In both the cases, we have to list what is initial velocity, what is final velocity, what is time. Then formula: acceleration is equal to final velocity minus initial velocity by time. So this negative acceleration is also called as retardation. Where speed decreases, retardation. Where speed increases, acceleration. So question number 8 is done. Now question number 9. In question number 9, what it is given in question number 9? Velocity is given. Amit is moving in his car with a velocity of 45 meters per hour, 45 kilometer per hour. How much distance will he cover in 1 minute and in 1 second? So here we know the speed, velocity given. Velocity is given. How much? 45 kilometers per hour. And time in both the cases. In first case, time is 1 minute. So what we can do, we can convert this 45 kilometers per hour into meter per second. How can we convert kilometer per hour into meter per second? Just by multiplying 5 by 18. You have to remember this. By multiplying 5 by 18, we can convert this into from kilometer per hour into meters per second. So now 9 2 is 18, 9 5 is 45. So what it is? 25 by 2 meter per second it is. Now we want distance covered by him. So what is the distance formula? Distance is equal to velocity into time. Now velocity is 25 by 2 into 1 minute time. 1 minute is how much? 60 seconds. So we can cancel it. 2 ones are 2 30s are. So what it is, 750 meters in the first case. In the second case, what happened? Same again formula, distance is equal to, this is A. Second case, velocity into time. Here velocity is same, 25 by 2 meter per second. But here in this case it is given only 1 second time. 1 second time means we have to multiply only 1. So what will be the answer? 25 by 2, which is 12.5 meters. In 1 second 12.5 meters. In 1 minute 750 meters. Hope you understood question number 9. Now let us see question number 10. In question number 10, read the question carefully. The odometer of a car reads 2000 kilometers. Initial distance is 2000 kilometers at the start of a trip, and 2400 kilometers at the end of the trip. 2000 kilometer at the start and 2400 kilometers at the end of the trip. Then what is the distance travelled by him? Distance travelled by him is 2400 kilometers minus 2000 kilometers, which is 400 kilometers. So we have to find out what is the distance first. Distance travelled to cover the trip is equal to just 400 kilometers. It is just 400 kilometers. Now what it is given, if the trip took 8 hours, time is given, time how much? Time is equal to 8 hours time. 400 kilometers in 8 hours. Calculate the average speed in kilometers per hour, meter per second. What is speed? Average speed. Average speed is equal to total distance covered by total time taken. What is the total distance covered? 400 kilometers. And what is the total time taken? 8 hours. So what it is? 8 ones are 8 fives are 40. So what it is? 50 kilometer per hour. They are asking in both kilometer per hour and meter per second. So 50 kilometer per hour can also be written as 5 by 18 meter per second. So what it is? 250 by 18, which can also be written as 125 by 9 meter per second. This is what in meters per second, this is what kilometers per hour. So whenever you want meter per second, the speed should be multiplied by 5 by 18. An electric train is moving with a velocity of 120 km per hour. How much distance will it move in 30 seconds? See here, question number 11 also, it is given speed. Speed, how much it is given? Or velocity, let us take it as velocity. Velocity is given 120 km per hour. But time is given only 30 seconds. So what it is better? Better you convert this 120 km per hour into meter per second. So velocity can also be written as 120 into 5 by 18. Now we get in meter per second. So what it is? 6 3 is 18, 6 2 is 12. So it is what? 20. So what it is? 100 by 3. 20 into 500, 100 by 3 meter per second. We want in 30 seconds. So distance is equal to speed into time. So here speed only it is given. So what is 100 by 3 into time is given 30 seconds. 3 ones are 3 tens are. So what it is 100 into 10, 1000 meters, which is nothing but 1 kilometer. In 30 seconds it can move 1 kilometer. Hope you understood question number 11. Now question number 12. If you see question number 12, in question number 12, a body is moving with a velocity of 15 meters per second. Here also velocity is given. Velocity is 15 meters per second. It is given in meters per second. If the motion is uniform, what will be the velocity after 10 seconds? Now velocity is uniform. Velocity is uniform. When velocity is uniform, there is no change in velocity. Given velocity is uniform, then there will be no change in velocity even after 10 seconds also, because it is moving with uniform velocity. Next, a train travels some distance with a speed of 30 kilometers per hour and returns with a speed of 45 kilometers per hour. Calculate the average speed of the train. So very simple, average speed will be average speed how do we calculate? First it is 30 kilometers per hour, so 30 plus, later it is 45 kilometers per hour, so 45 divided by 2. Generally how we find average? Total divided by number. We have two cases, so average velocity will be 30 plus 45 by 2, which is 75 by 2, which is 37.5 kilometers per hour. This is what average speed of the train. Question number 14. What we have? Question number 14. A train 100 meters long moving on a straight level track passes a pole in 5 seconds. Find the speed of the train. So here 100 meters long. Length of the train is given. (100 meters) and it took the time 5 seconds. So here length of the train only distance travelled by the train. We have to understand it. Length of the train is nothing but distance travelled by the train, and the time is what? 5 seconds. So what we can do? We have to find out speed of the train. Speed of the train is equal to distance by time. So what it is? 100 by 5. After cancellation it is 20 meters per second. This is what speed of the train. But now one more, the time it will take to cross a bridge 5 meters long. We have to find out the time. Cross a bridge of 500 meters long. Bridge of 500 meters long. So here what we have to do? We have to find out time. Time is equal to what? Distance by speed. Time is equal to distance by speed. Distance is 500 meters and speed we got 20. So what happens? 0, 0 cancel, 2 ones are 2, 25 are. So what it is, 25 seconds. It takes 25 seconds to cross 500 meters long bridge. A car travels along a straight line. Question number 15. Let us finish after this 15. We will conclude the video. Remaining we will discuss in the next class. A car travels a long straight line for first half time with a speed of 40 kilometers per hour and the second half time with a speed of 60 kilometers per hour. Find the average speed of the car. Again same, average speed is equal to average speed is equal to total speed. Total speed is what? 40 kilometers per hour sometime plus 60 divided by 2. So what is the average speed now? 50 kilometers per hour. That's it. Hope you understood today's problems. I'll come with one more video in which we will discuss some more numerical problems in motion as well as derivation of laws of equations of motion and graphical related problems, graph related problems also. So if you are watching first time, subscribe the channel, like it, share it. Thank you.